the questions like how fast, how heavy, how much, etc. So in this lesson, we are going to discuss about the fundamental and derived quantities and their units, the rules to be followed by expressing physical quantities in SI units. We will get familiar with the usage of scientific notations, know the characteristics of measuring instrument, uses of vernier caliper and screw gauge for small measurements, and find the weight of the object using a spring balance, know the importance of accurate measurements. Now, coming to physical quantities and its units. So what is physical quantities, children? Anything can be measured is called as physical quantities. What are the things you will measure, children? Your chairs, table or the smart board, you can measure these things. So this is called as physical quantities, and it is subdivided into two categories, fundamental quantities and derived quantities. We can see the definition, children. Fundamental quantities, quantities which cannot be expressed in terms of any other physical quantities are called as fundamental quantities. For example, length, mass, time, etc. So I will tell you an example, children. When your mother wants you to buy some tomatoes, how will you ask for your when you go for the shopkeeper, children? Will you ask, give me 2 liters of tomatoes? No, you will ask, give me 2 kilograms of tomatoes. Correct, children? So the unit of length is meter and the unit of mass is kilogram. It cannot be interchanged. Okay, these are called fundamental quantities. Next, we can see the definition for the derived quantities. Quantities which can be expressed in terms of fundamental quantities, that is derived from the fundamental quantities. Okay. See, for example, area, volume, density, etc. So for expression of areas, length into breadth. You know, length is a fundamental quantity. Breadth is also a fundamental quantity. We are deriving the area which is derived quantity from the fundamental quantities. So it is called as derived quantities. It is derived from the fundamental units. Okay. Then the expression for physical quantity is length into breadth, children. Now I will tell you how to find the unit or how to derive the unit, children. First, the unit of length, as you know earlier, it is meter, and the unit of breadth is also meter. Okay, so meter into meter, you get meter square. That is the unit of area. Are you clear, children? Next comes to volume. The expression for volume is area into height. So earlier we know the unit of area is meter square, and the unit of height will be meter. Listen, children, for the length, breadth and height, these three fundamental quantities share the same unit, meter. So meter square into meter gives you meter cube. You derive the unit for volume also. Next, I'll say you another example, density. The expression for density is mass by volume. So, as you read earlier, the unit for mass is kilogram. By the unit of volume is, you have derived this earlier, meter cube. So, you can write it as kilogram per meter cube. Understood, children? This is the simplest way of deriving the units. So, don't memorize it, children. Next I am going to tell about the larger units. Okay, children, what comes to your mind when I'm asking you about the larger units or larger bodies? Yes, the astronomical objects, the sun, the planets, the natural satellites, etc. So the larger units are nothing but these are the units which used to measure the distance between the larger unit. I'll repeat it, children. The distance between the larger unit can be measured by using larger units. There are three kinds of larger units. They are astronomical units, light year, parsec. See, what's the meaning of astronomical unit? It is the mean distance between the center of the earth and the center of the sun. Okay, it is the mean distance between the center of the earth and the center of the sun is called as one astronomical unit. And they have derived one astronomical unit is equal to 1.496 into is nothing but it's a distance traveled by light in 1 year in vacuum, and it is equal to 9.46 into 10 power 15 meter. Okay, light year is nothing but the distance of meter traveled by the light in vacuum. You know what is the meaning of vacuum, children? Vacuum means there will not be any matter without any air also. Okay, children, that is called as vacuum. So next we are going to see about parsec. Parsec is a unit of distance used to measure astronomical objects outside the solar system. Okay, what are the objects you see outside the solar system, children? There will be meteors, asteroids, natural satellites, everything. Okay, so measuring the distance of these objects outside the astronomical, outside the solar system, we will use this parsec. So 1 parsec is equal to 3.26 light year. Okay, then 1 light year is equal to 9.46 into 10 power 15 meter. Next, this is an important thing to be followed, children. There are rules and conventions for writing SI system and their symbols. It is very essential to write the symbols and units in a very correct manner, children. So these are the points given to write it in a particular way. How to write the symbols accordingly. First one, the unit name after scientists are not written with a capital initial letter. Example, Newton, Henry, Ampere, etc. See, when you are writing the scientist, name of the scientist as a whole, you should start writing the first letter with small letter. You should not use capital letter. Okay, the second point, the symbols of the units named after scientists should be written by the initial capital letter. If you are using only initial, for Newton, you are using only N means you should write the capital letter. In that time, you should not write in small letter. Understood, children? Next, third one. Small letters are used as symbol for units, not derived from proper noun. So, small letters only should be used in the unit. M for meter and kg for kilogram. Next, no full stop or any punctuation mark should be used. There should not be any full stop or punctuation mark when you are writing the units. For example, 50 gram is correct. You should not write as 50 gram, point or comma. Okay, you should not write any punctuation marks here. This is wrong and this is correct. Okay, children? Next, the symbol of the units are not expressed in plural form. So you should not use plural form in the symbol. You should write only 10 kg and not as 10 kgs. You know, plural form should come here. Okay, only singular form should be used in writing the units. Next, when temperature is expressed in Kelvin, when you are writing temperature in Kelvin, you should not use the degree sign. Okay, the degree sign. You should not use the degree sign. When you are writing in Celsius, you can write the degree. Okay, children? So, 283 Kelvin. You should not mention degree. If you are writing in Celsius, 100 degrees Celsius. Okay. Next, use of solidus. Solidus means like this bar type, children. It is recommended for indicating a division of one symbol. So, only one solidus should be used in a unit, children. See, meter per second. For this meter per second, you can write like this meter per second. Only one solidus should be used. Then, you should not use more than one solidus. See, for example, children, this is joule per Kelvin per mole. So you should write like this only, children. So they are more than one solidus. They are two solidus. You can see here, joule per Kelvin per mole. It is written like this. So it is wrong. You should write only one solidus. Otherwise, you can write like this. Standard form. Understood, children? Next, the number and units should be separated by a space. There should be space in between the numbers and the units. Okay? 15 space kilogram. Like that, you should make use of the space. Next, accepted symbols alone should be used. Accepted symbol, seconds, you can write yes. See, for ampere, it is only A, not AMP. For second, it is only S. You should not write as seconds. SEC. Okay? So now I hope you are thorough with using the symbols and signs, children. Now we can go to the next topic. Next topic is vernier caliper. So in your day-to-day life, you are using a meter scale. In the meter scale, it's graduated into millimeter and centimeter, which are using ordinary scale. Now I'm saying about that. It is calibrated into millimeter and centimeter. Okay, you can measure the objects up to 1 millimeter. And what about the objects which are below 1 millimeter? How can you measure that? We can measure using the vernier caliper. Okay, the uses of vernier caliper. What are the things we can measure? Measures length, width and height of the smaller object up to 0.1 millimeter. It measures object up to 0.1 millimeter. Then volume of the object can be calculated. An object's volume can be calculated. And inner diameter can be calculated. And inner volume can be calculated. See children, this is your image of the vernier caliper. And this is your upper jaw. This is your upper jaw and this is your lower jaw. And this will be your main scale. This will be your main scale. And the short scale you are seeing here, this will be your vernier scale. Vernier scale. Okay, children, so these are the parts of the vernier scale. And the object which you are going to measure must be placed between the lower jaw. It is a spherical shaped object. For a spherical shaped object, you cannot use ruler to measure. So you can use this vernier caliper, and it's kept inside the lower jaw, and the screws were tightened, and the readings you will see the main scale readings and vernier scale reading coincide at a particular number. So that number is taken as a reading. That is your final reading. So what is the use of the upper jaw? For upper jaw only you can see the volume. You can measure the volume. For example, a beaker. You are using the laboratory. Okay, the beaker should be placed here like upside down. Okay, beaker should be placed here in the upside down position, and the jaws are tightened up to hold the beaker tightly. Then the readings of the main scale and vernier scale can be calculated, and it shows the inner diameter, inner part. You can calculate your pen cap also, calculate the inner diameter of your pen cap also. Okay, so very minute things can be calculated in your vernier caliper. Next, we can see about screw gauge. Screw gauge works on the same principle of vernier caliper. Screw gauge is an instrument that can measure the diameters up to 1/100 time or 0.01 millimeter. Vernier caliper measures 0.1 millimeter. Screw gauge measures more smaller objects, 0.01 millimeter. Up to 0.01 millimeter objects can be measured through screw gauge. In this, you can measure your diameter of your hair also. Okay, children. So this is the image of your screw gauge, children. The object which you should measure should be kept inside in between this finger, and the screw is rotated to make the object tight, and the readings you can measure in the main scale and the circular scale reading, which gives you the approximate reading of your measured things. Next, now I am going to tell about some of the instruments which are see about differences between mass and weight, children. So we can start from the third point. In mass, it is the amount of matter contained in the body. Mass is nothing but only a matter in the body. Okay, so for example, if you're weighing around 1 kilogram of rice, it will be 1 kilogram of weight of rice in everywhere. Okay, whether it's an Earth or any other planet, the weight will not change. Okay, but rather it is a normal force exerted by the surface of the object against gravitational pull. When we are talking about weight, your weight depends upon the gravitational force which you receive from the earth or moon, etc. See, for example, if you are weighing around 30 kilograms in earth, will you weigh same kilograms in your moon? No, because the gravitation in the moon is much lower than the earth. Okay, so your weight will be reduced when you are in moon. So it is a weight totally depends upon your gravitational force. Okay, then it is mass is a fundamental quantity. You have read this earlier about the fundamental quantity, and weight is a divided quantity. It has magnitude alone, so it is called a scalar quantity. Mass has magnitude alone. It contains only matter, so it is a scalar quantity. But weight, it has magnitude and direction. It also contains matter, and it also varies in directions. Okay, it also varies from place to place. So it is a vector quantity. Mass is a scalar quantity and weight is a vector quantity. Next, remains the same everywhere. As I told you earlier, mass remains same everywhere. Whether you are on Earth or you are in any other planets, your mass will be same everywhere. This varies from place to place. Weight varies from place to place. When you are on Earth, you will show a different weight, and when you are on a moon or other planets, your weight will vary accordingly. It is measured using physical balance, and it is measured using spring balance. And the unit of mass is kilogram. The unit of weight is Newton. So your weight is not your weight, children, it's a mass. So only they are saying telling that body